will lead the discussions. So as you can see here, that we will provide you the hands-on training by using flood prototype model for the simulations of the natural disaster, particularly focused on the flood, and also the visualizing the data. I think you guys already downloaded the Excel file, which we asked you yesterday, and also the data cleansing, and followed by the interesting cross analysis between the natural disaster and the transportation control. So those are the program for 2.5 hours till 11:30, and we may have a break in the middle. And followed by the hands-on training, we may have short introductions of the best practice use cases in Japan by myself, and the other countries means Latin America case. We have a very unique now prevail in Latin America countries. That's what we call EWBS, Emergency Warning Broadcast System, by using the broadcast radio waves. And that is the low latency and wide coverage and the robust transmissions. And we would like to invite Mr. Sakaguchi-san of JTEC. Actually, he has been engaged this EWBS area over the years. So he knows very well about EWBS. We call him the legend of EWBS. So he will give you the presentations about the best practice about Latin America countries. Sakaguchi-san, can you show your face? If you are there.
Good morning, everybody.
Okay.
Good morning.
Sakaguchi, good morning. Thank you.
Yeah. So he will be back maybe 11:40 your time around. So looking forward to his presentation. So I may pass the microphone to Yasumura-san to kick the hands-on training today. Yasumura-san, please.
Okay. Thank you, Naito-san.
Nishikawa-san.
Good morning, everyone. Thank you, Naito-san. This is a first opportunity for us to present IoT hands-on training for Indonesia. This is our challenge of digital transformation to our capacity building program. This training course is following the Nishikawa-san's concept in the lecture of day first. I'd like to thank you, all of you, for your kind attention in advance. So let's start the training.
This training is not aimed for discuss the solutions for floods. It is aimed for learning the basic components of IoT and learn its benefits of data collection and its usage. By using the prototype model and changing the parameters, you can experience DX, digital transformation. Each part of the hands-on training is relating to these objectives. And finally, you would like to challenge using IoT. Let's try.
Just a moment. I just changed the set of the conditions for the sharing. このシェアサウンドだ。そうです。OK だ。それで、ノー。こっちをシェアすればいいんだ。So, like this slide, we will use the automatic narration. If you have questions, please write it down in the chat. We will respond to you time to time. Okay? これで、20。次。
Firstly, please watch the video showing the mechanism of flood prototype model.
で、これが今置いて、ポーズ。で、一遍落として、これだ。見えてる？ So this video is showing the how we make flood in our prototype model. The water from this pipe is going down to the river. This river tray is the inner concept river. So you can measure the water level from this. So water level increasing gradually this way. And please look at these red marks. This is a wall to the town street. And there are small holes here, here, and there. So this is 3 centimeters from the ground, 4 centimeters, and 6 centimeters. So from those holes, water will go into the town street. So now the water levels, if you see. So here's the drainage. We have a drainage for both river and for the town streets. We will explain later how we set this drainage. So this pipe is connected to the city street. So this is the inside of town streets. Here are walls and holes. And this is a sensor, tilt center sensor for catching the flash flood. The water level of river is increasing. Then please watch here. The river water is now going into the towns. So in this demo, we put the tilt sensor to find out to detect the flash flood this way. Now going to the second hole. Third one. So please regard this as a small real world which we made to get the data from this real world. And now the water level is decreasing by opening the drainage. Here and here, we put on water level sensor later. Okay. これでこういうな。で、今度はまたここに戻ってくる。Okay.
You may see how the water level of river increases and the water flows into town street, but you cannot say when it happened and how fast it happened.
This question comes from Nishikawa-san. He would like you to think of what data you want to collect from real world. This time, water level, as you saw, and also we think its time is important to analyze the flash flood.
Let's review the mechanism. River tray stands for river, and town tray stands for streets in towns. By the volume of pumping, we can increase and decrease the water supply to river tray. By putting in or taking out the plugs, we can open or close the drainage for river and town.
So please remind the video. So there are two trays. In the base, water tray. We keep around 3 liters of water here. And the water will go down to the town tray, river tray, through the this pipe. Then the water in the river tray will comes into the town tray, and through the drainage, waters go out to the return to the water tray. So we don't have to afraid of the overflow of waters in this model. And here's the pump. We bought a pump for aquarium, and changing the volume, we can change the intense of this pumping. And look at the pictures. River tray stands for rivers, and the town tray stands for town streets. Please imagine those situations in your mind.
To set the conditions of embankment, we can open the holes a little bit by removing the vinyl caps covering the holes.
So we can change the holes in the embankment by changing the place of the hole, changing a vinyl cap. But to make a comparison between the patterns, we use the fixed place of hole in this model.
I would like to compare. I would like to compare factors of flood in real world and in the model. This comparison shows the linkage between the factor of floods and parameter of flood prototype model. Rainfall intensity is linked with pumping power, height of embankment linked with height of town wall hole, and water flow capacity of river and town are linked with drainage of river and town. by measuring data 1, 2 and 3, we can use the data for AI, such as binary classification analysis and regression analysis for predicting flood occurrence. By setting the sensors and sensor network, we can monitor the flood status time to time with data. IoT is a tool to present the physical status of things in cyber world with digital data. In this hands-on training, sensors are not connected via Internet, but we are using wireless data transmission, and you can learn how to convert physical status of river and town street water level to real-time cyber digital data and learn the flow of data. This is not a training for fostering engineers. If you understand the mechanism of IoT and obtain the image on how to utilize IoT for solving social issues in the fields and how to use the data, it is our success of training. If you know the overall picture of the system, you can have a productive discussion with engineers. So, let's set IoT mechanism to this flood model and visualize the floods. This slide shows how the sensing mechanism of water level sensor. Magnet on the top of float, will switch on the reed switches when it reached each height.
Okay, so by using a camera, let us see the actual sensors by the as a hands-on training. So would you please look at the video of APTA. Click the click the right side and then put pin. So you can see the larger size of the video of the prototype model. Can you see the sensor?
もうちょっと縦にして。
This is the
Lead switch.
Lead switch. So this is always the number 1, 2, 3, 4. When the this road come to the number 1 lead switch, that is 2 centimeters from the ground. 3 centimeters, 4 centimeters, 5 centimeters. So this move on the top of this floating, this is a magnet. Magnet will switch the sensor one by one. And when this wheel is between the sensor 3 and 4, we designed to have a 3.5 centimeter in the monitors. And this is the sensor itself, switch equipped in the model. Yeah. There's a place of sensor 1, 2, 3, 4, and connecting the signal with this line. Those are the sensor mechanisms. Okay. Okay, let's return to the presentation. もうちょっと後で。あれ、どこだっけ？これを元に戻すのはどうするんだっけ？これだ。シェアスライズ。こっちだね。左じゃないですか。こっちで、シェアだ。ね。あれ次に行けない。10で、こうだ。
After testing several patterns of parameters, we choose these 3 patterns for your experiment. The height of embankment, town wall hole and river drainage is the same condition. We changed the rainfall intensity, namely pumping power and town drainage. Let's see how we set these parameters through the live camera.
で、これをポーズ。で、ストップシェア。then、これをピンと。then、
また、ピンは直してくださいって言ったんです。Again, pin.
So Mr. Iwasawa will share the monitor screen. So please find Iwasawa-san's screen. Did you find out? Then, so please move the cursor in the between the camera and the monitor to the center. So you can see both monitor screen and camera. JTEC APTA. Okay. Then we'll show you the movement of actual water.
そんなやつは映ってない。
First of all, please watch the light.
みんな見えてますかね。
So this is a pump. Pump, and volume. And,
Do you see the live video? Everybody okay?
We see only the dashboard for the
Desktop.
the left side is a river and the right side.
Yeah.
Town
So
street.
also we are sending the video, live video of the water model.
JTEC APTA. Please look at JTEC APTA.
やり方わかんないね、みんな。
わかんない。
もうよくわかんないな。自分でもどう出していいのか。
はじめさん
Yes.
Can you see the monitor screen?
Yes. Monitor screen.
Yes.
Yeah.
So-
the dashboard. Yeah.
Right hand side, you may have the view of the gallery. View of the participants. Right hand side. Right hand side maybe.
Yeah. Yes.
Please select JTEC APTA. Then
Yes.
click the mouse right. You will see the pull down menu and choose P. PIN. Then the video will focus.
Oh,
Yeah,
I see.
yeah.
Yeah. Okay.
Okay.
Yeah. Yeah.
Okay.
I see. I
The
see. Yeah.
desktop. Can you see the both desktop and video movie? I mean,
Yes.
Okay. So I go to the camera. So first condition は何だっけ? To set the pumping power, we use this. Switch on. Then water pumping. Other or solar. This is a water pump. Water pump. The downward pole is here. Those poles. We can change the condition. And the next one is a river drainage. A drainage for river. This one. This drainage is connecting to the river. And the other one, this drainage is connecting to the town street. So we can change those conditions to have a various patterns of flood model. Okay, thank you. So let's go to the next slide. 岩沢さん、please share, stop sharing. 動かすんだっけ？動かすんだっけ？動かしてみようか。もう一遍、コネクトアゲン。せっかくだから。OK。I switched on the pumping. 見えてない。またこっち戻して。
Can you see the live video? Everybody.
いや、どういうふうに見てるかわからないです。赤いやつは。
Now, flashback of the town street. And the rivers in the town riding.
Okay. Okay, thank you for watching the live demonstration. Let's close the current videos, please. Finally. Okay. Review.
If you record the time of water level, you can calculate the speed of rising water level by elapsed time. We will analyze the speed of water level at exercise with Excel.
Do you have any question? Three question. どんなクエスチョン？後でも構わないの？流れがあると思います。Okay. So firstly, I will explain this a little bit, please look at the river 0 to 2 centimeter elapsed. In the pattern number 1, it takes 72 seconds. In pattern 2, 58 seconds. Pattern 3, 77 seconds. This means the increase of water in pattern 2 is higher or faster than the other two patterns. Same as in the town 2 to 3 centimeter elapsed. Pattern 1, 152. Pattern number 2, 22 seconds. Pattern number 3, 104 seconds. So those difference will show us, give us some image how fast in pattern 2 flood was caused so quickly.
Please watch the experiment for pattern number 1. Please watch how the water levels go up and down and how the monitor display shows the water level changes. After watching the video, we would like you to make a line chart with the data of pattern 1.
Okay, so we showed the live demonstration, but some of the participants may not watch how it works. So we prepare the videos for this. So there's no narration here, but left upside, there's a monitor screen of water level in river and town street. Right upside, this is the pictures for inside of the town streets. Now we start the pumping and water comes into the river. Okay, so the sensor here detects the increase of water level of river and shown in the monitor. No water into the town street right now. Oh, the water goes into the water town street when the water level, river water level is 3. Please look at the leaking waters. And those floats, this float coming up gradually. This may be the second water leaking to the town street. Now the sensor in the town street catches the water level too. Also, please look at the drainage of town street, this water. Now it looks like a stable status. The water drainage is working, and water level of town street is stable at 2 centimeters. Then the rain or water supply increased into the river. Please watch around here. We increase the water supply to the river. So now the sensor comes to the top level for the river. Here, increasing, this is the plot for the town street. Quickly, so this means that because the sensor goes over the highest sensor, so there's no data for this monitor. Instead, water level town street comes to the highest level. So we think the flash flood comes into the town street and take off the drainage for river and decrease the water level to the end of this demonstration. So sensor detected the lower water level and showing on the monitor. Okay, this is the demonstration of video of the pattern 1. So next.
Please watch the experiment for pattern number 1. Please watch how the water levels go up and down and how the Please try to use Excel file to make a line chart for pattern 1 and visualize the collected data. Firstly, let's try to make line charts with the Excel file we sent beforehand. Please open the Excel file and try making the charts for pattern 1.
Oh, sorry.
This
Okay, so as we informed beforehand, we are going to make a practice or exercise using Excel files which we sent. Just a moment. This is the Excel file which we sent you. I'll show you the example. So this is the P1 means pattern 1. This column ABC is a data of the we collected from the pattern 1. So we drag these data. So we have almost more than 1,000 data from this about 8 minutes demonstration. And this column A, timestamp, is showing the when the data comes in. これ何秒後でしたっけ？このデータってインターバルは。
書いてないな。
書いてない。
1秒、大体1秒。Around one second.
Around 1 second. The interval of the data was around 1 second. Then we choose the insert button. Then choose the line chart. They just choose the first one. Then you will make this graph. You can enlarge this. Then you can choose the appropriate size of the data. This is originally a line chart, but because there are so many data, it shows these types of the showing the status of water level. これ表現のどれするんだっけ？これチャートタイプじゃない。もっとガーッと数字で表現。
これまずこれ選んだら、見えないの？
見えないのこれ。
あれを選ばなきゃいけない。上のタブを。それじゃ見えないし、そっから長く。
Okay. You may, もういいか。You may see how you do this. So, please go back to your PC, open your file, then try to make this type of this chart and change the size and so try to analyze by yourself how is the how would you like to make this graph for your analysis? Okay, so you may have 10 minutes to do this exercise. After 10 minutes, will please come back to the video. Thank you. なんかわからないってあります？
3つ言われてるんですね。
はい。
で、ウォーターフォールはどこにローケーテッドしてますかって。タウンウォールフォール。
River.
タウンウォールフォール。Where exactly the town wall hall are located? Are they set on the street and on which parts that can be opened and closed?
ちょうどだから、
これ何言ってんの？まあちょっと答えましたけどね、僕。だから
ちょうど10時にね。
はい。最初の3つの質問で西川さんに書いていただいてるんですけど、もう一つ質問が来て、それはタイムインター、センサーデータのタイムインターバルについて、で、安村さんが、
口頭で、
エクセル見せたときに、何セカンド答えたので、一応答えたことにはなる。
ちょっとデータが少し難しい。
質問がちょうどこれ来てるから、
はい。
答えるとって一言付け加えると。
なるほど。
データが変わっちゃってる。いや、もともとデータちゃんとセカンドに入ってます。
はい。